This is 4.4, Understand Slope of a Line, and we'll be in Section A. This is from OpenStax Elementary Algebra. So before we get into 4.4, we're going to do our readiness quiz. Go ahead and pause the video and solve these out, and then come back to make sure that you remember these concepts. So hopefully you've taken the time to do these on your paper. Let's go ahead and go through these. Simplify. Remember, when we're simplifying, we first do the top and then separately do the bottom, and then if we need to, we reduce from there. So 1 minus 4 is negative 3, and 8 minus 2 is 6. And then this can be reduced because 3 is a factor of negative 3, and 3 is also a factor of 6. So that's negative 1/2. And of course, you can write it this way if you want. I don't care which way you go. I prefer to put the negative on the top with the numerator. That way, as I'm moving it around, that negative just goes with it. Okay, divide 0/4 by 4 over 0. Now, what is the problem with this? We can't actually do this, right? Because you can't divide by 0. So this has no solution. It was kind of a trick problem, a trick question. So remember, you cannot divide by 0. So we can't even do this. Let's do the other one though. What if we did 0 divided by 4 by itself, not dividing it by 4 over 0? What if we did 0 divided by 4? What would that equal? That is equal to 0. 0 divided by anything is 0. So remember, if 0 is in the top of the equation, it's 0. If 0 is in the bottom, it is undefined or no solution. And then we have simplify. So remember, it's just trying to get you to remember and to bring to the forefront of your mind that it doesn't matter where the negative sign is. 15 divided by negative 3 is negative 5. Negative 15 divided by 3 is also negative 5. But then here we have a negative on the 15 and a negative on the 3. So we have a negative divided by a negative, and that is equal to a positive. So this one is positive 5. Okay, if you didn't get those and you need some help reviewing, please let me know. I can direct you to some resources for that. So let's go ahead and get into A. Use Geoboards to model slope. And I am so sad that we don't get to do this in class together. Slope is a really fun concept to learn and to teach, and I actually have Geoboards at school in my classroom that we could have gotten out some rubber bands and done some very hands-on learning. Unfortunately, we are not in the classroom together, so we're going to have to do it visually. So hopefully when we get back in the fall, we'll be able to maybe just go back and do some of those hands-on things together. So let's first, what is a geoboard? A geoboard is a board with pegs, and then rubber bands can be placed on the pegs to model a line on a plane. So we can imagine this as a part of a Cartesian plane, right? An XY coordinate axis plane. And then if you put a rubber band from one peg to another peg to any other peg on there, it will create a straight line. And so that's what a geoboard is. Once we've created our line on there, then the rubber band can then be stretched to create a right triangle such that the original line is the hypotenuse. So if you look on the board on the bottom, this was our original line, right? Our original line was here, but then they stretched up the rubber band, the one side of the rubber band, to make a right triangle so that that original line was a hypotenuse. It's not one of the sides that meets the right angle, it's opposite the right angle. Okay, you always want your original line to be opposite of that right angle. This helps us find the slope of the line, and we're going to be talking about what slope is. So just in terms that we would use it in speech when we talk about the slope of a hill, or wow, that's a really steep slope, right? We're talking about uphill or maybe downhill, right? You can slip down the slope if it's downhill. And so that's what slope is. Slope is defined, well, loosely defined as the amount a line goes up or down in math. So let's go ahead and get a formal definition of slope. So the slope of a line. The slope of a line is this formula. M, this stands for slope, is equal to rise over run. rise over run. Okay, so this is something you need to memorize. You're going to use this for the rest of your math career. The slope is rise over run. The rise, think about what rise means. Rise means to go up, right? Jesus told his disciples he would rise from the dead, right? We rise and shine, get up and out of bed. So rise measures the vertical change between 2 points on the line. The vertical is the up and down, right? How much it rises. You put bread out in a warm spot to rise, to get higher. And then the run, when you run, you don't run up and down. You run horizontally. Run measures the horizontal change between 2 points on a line. Okay, so that's what slope is. This, you need to memorize this. Slope equals rise over run. Slope equals rise over run. So when we are looking at a line, oops, sorry guys, forgot to switch it to pen. Okay, so when we're looking at a line, if our line goes like this, from one point on the line to another point on the line, we can measure the rise, the change, the vertical change, and the horizontal change, and then we can put that into our slope formula. So let's look at it with that band that we had on the previous slide. Let's see, I'm going to pick a color that's way different here. Okay, so in this case, the rise, the vertical change, is 1, 2. So the rise is 2, and the run, or the horizontal change, is 1, 2, 3. So the run is 3. So the slope of this line is 2/3. Now slope is always going to be in a fraction. Well, it's always going to be in some form of a fraction, right? Even if it's a whole number, let's say the slope is equal to 3, then what that means is that it's equal to 3 over 1. The rise is 3 and the run is 1. If it's in decimal form, then we can change that to fraction form, right? 3/2. Okay, so it's always going to be able to be expressed as a fraction at this point in your math career. So the slope is rise over run. How far you go up and how far you go horizontally, up or down, and how far you go horizontally to get to another point. So let's do an example. It says, what is the slope of the line on the geoboard? So we're going to go between 2 points, and you always want to go where it meets integers on the Cartesian plane, or in this case pegs. Okay, so we want to go from here to here. Okay, so we're going to find the slope, and so we know that slope is equal to rise over run. So first we need to count how far it goes up. So let's go ahead and draw our, oh, that's horrible. Let's draw our right triangle, and let's go ahead and count. 1, 2, 3. So the rise is 3, and the run is 1, 2, 3, 4. So the run is 4. So in this case, the slope of this line is 3/4. Okay, try it. Here are 2 geoboards. You are going to find the slope of the lines on the geoboard. So pause your video and go ahead and find those slopes and then come back. Okay, so for the first one, let's count. Sorry, I did it again. Okay, here we go. Let's count up. 1, 2, 3, 4, and 1, 2, 3. So if it's rise over run, the rise was 4. Oops, and I forgot to write it here. And the run is 3. So the slope of this line is 4/3. Now let's do the next one. Our rise is only 1, and our run is 1, 2, 3, 4. Rise over run. The rise was 1, and the run was 1, 2, 3. I said it was 4. So it's 1/4. So this is the slope of the second geoboard. Check your answers. If you don't, if you missed them, go back and see why you missed them and make sure that you understand. Let's look at this one. Example 4.26. What is the slope of the line on the geoboard? So remember, slope is equal to rise over run. But something's different here. Okay, something's different. Our right triangle goes in a different direction. So to go from this first point to the second one, we actually have to go down. We always start with the point that's on the left and go to the right. We go in increasing direction of the x-axis, or the same direction that we read numbers. Okay, so we're going to start here and we go down 1. So what is the change in value from here to here? It's -1. Okay, so you have to put a negative if you go down. And then the run is 1, 2, 3. So in this case, the slope is -1/3. Okay, so here we see that slope can be negative. If you start on the left and go to the right and you have to go down, then the slope is going to be negative. Let me throw up 2 try it problems here. Go ahead and pause your videos and then come back. So let's do the first one. To get from our first point to our second point, we have to go 1, 2, but we're going down, so that's negative, sorry, not 3, -2. And then our run is 1, 2, 3. So the slope of this line is -2/3. Let's go over here. To go from left to right, the first one to do the vertical, we have 1, 2, 3, 4, but it's down, so it's negative, and then 1, 2, 3, -4/3. Okay, so I hope you noticed something as you were doing these. The last 3 we did were negative, and the ones before that were positive. So what did you notice about the correlation between positive slope, negative slope, and the line? Hopefully you noticed that positive slope lines go like this, and negative slope lines go like this. Okay, so positive slope, as you're going from left to right, it's like you're going uphill, right? As you're going from left to right, positive slope goes uphill. Negative slope goes downhill. And you always go from left to right. Okay. Now, the positive and negative does not indicate the amount. That would be the numbers, right? Positive, that's still positive. This is still positive. Oops, that was a horrible sketch. I'm going to try to do it. This is still positive, right? As long as it's going uphill from left to right, it's still positive. Same thing with negative. It doesn't matter how negative, how steep, or how not steep it is. As long as it's going downhill from left to right, it is a negative slope. Those are kind of the same, but you get the idea. Okay, so positive slopes, as you're going from left to right, they go uphill, and negative slopes, as you're going from left to right, they go downhill. So keep that in mind. That's very important. Okay, now you're going to use the geoboard to model a line with slope 1/2. Okay, so we're actually just going to draw it on here. Now you can pick anywhere to start as long as you leave enough room here. I know I'm going to have to go up 1, and I'm going to have to go to the right 2. So I'm going to start right here. Just pick this one. I wouldn't want to start up here, right? Because there's nowhere to go. I can't go up and I can't go over. So that would not be a good place to start. So I'm going to start right here. And then I need to go up 1. So up 1 and to the right 2. 1, 2. So this is my ending point. And then my line is actually the line that connects those 2 points. And it would be better if I was doing this on paper with a ruler, but I'm going to just do it that way for now. Okay, so that's how you use a geoboard to model a line when you're given a slope. So I'm going to put up some try it problems for you. Go ahead and reproduce this on your paper, and then model lines with slope 1/3 and 3/2. To help you out, I'm going to rewrite this here, rise over run. Okay, so you know the top numbers, the numerators are the amount you go up or down, the horizontal direction, and the run is the number you go to the right. So pause the video and come back. Okay, let's do 1/3. I'm going to start in the same spot here, and I'm going to go up 1 and to the right 3. 1, 2, 3. So I'm going to end here, and then the actual line is connecting those 2 points. So this is the line. Now you may have put it somewhere different on your Geoboard, and that's fine, but it should be that same steepness. Okay, now let's do 3/2, 3/2. So notice this is an improper fraction. It's not going to change the way we do it. I'm gonna start in my same spot, and I'm going to go up 3. 1, 2, 3, and then I'm going to go to the right 2. 1, 2, and then I'm going to mark that and connect those points as best I can, freehanding it on the computer. There we go. And that is my line. Okay, so it's still positive. 1/3, so we have a fraction that's under 1, and then 3/2, we have an improper fraction, but they're both positive, so they're both going uphill as you go from left to right. Okay, next. We're going to use a Geoboard to model a line with a negative slope. So it's -1/4. So remember, -1 is the rise, which means I'm actually going down, and 4 is the run. So if I need to go down, I want to start up in the upper portion of my Geoboard. So I'm gonna start in this top corner, and I'm gonna go -1, and then I'm gonna go to the right 4. 1, 2, 3, 4. That's going to be my ending point. And then the line is actually between those 2 points. Kind of draw. Okay, you get the idea. Hopefully yours looks better, but it should look something like that. Notice, because it's a negative slope, as we go from left to right, it goes downhill. Negative slope. So 2 try it problems. Go ahead and use the Geoboards to model these negative slopes, -2/3 and -1/3. Pause the video and come back. Okay, let's start with -2/3. Since we are working with negative, I'm going to start in the top corner because I know I'm going to have to go down. So I'm going to go down 2, 1, 2, and over 3. 1, 2, 3. When we go over, we're always going to the right. Okay, we're always going to the right, but as far as up and down, we go up if it's positive and down if it's negative, but we always go to the right. So there's that line, and that makes sense, right? It's a negative slope, and as we go from left to right, it's going downhill. Now let's do -1/3. So I'm gonna use the same starting point. I'm gonna go down 1 and then over 3. 1, 2, 3. And then I'm going to connect those points, there you go, something like that. Okay, and once again, it's negative slope, and as I go from left to right, it goes downhill. So that's how you use Geoboards to model and to show slope. So go ahead and check Google Classroom for your assignment. If you have questions, please don't hesitate to reach out to me or leave a comment on Google Classroom.